When we think of multiplication of fractions, we have two strategies or two models we can use. When we multiply 1/2 times 3/4, we can also put this into words, and we can say that we have 1/2 of a 3/4 fraction. Well, if I were to do that, well, what does that look like? I have a 3/4 fraction. I'm going to shade that in. I have my 3/4 fraction, and if I want 1/2 of this, really I can just take one piece here, one piece here, one piece here. That's going to be 3 out of 8. So 1/2 of 3/4 is 3 out of 8, and I can see this in words because I'm taking 1/2 of a 3/4 fraction. And we also know that we have top times top, bottom times bottom, so it will give us the same thing. So the diagram's here. I have 3/4, and I'm going to divide these quarters up into halves. There it is. I have my 3 out of 8 pieces. So our rule for multiplication of fractions is going to be top times top, and then bottom times bottom. And we can show this shows up in our area model as well. So if I were to do 1/2 times 3/4, there's one along the vertical, one along the horizontal. 1/2 times 3/4 along the vertical. That would be represented by this area here. 1/2 times 3/4. And we can clearly see that the top times top, the 3 pieces vertically, 1 piece horizontally that we want in our numerator. And our denominator is what makes up the whole. We have 2 pieces on the bottom, 2 pieces along the horizontal, 4 pieces along the vertical. So we have bottom times bottom, which gives us the number of divisions that make up the whole. So this, we can see very clearly how our rule of top times top, bottom times bottom shows up in our area model. So when we look at these two fractions, we can compare these two fractions as a ratio of comparison. So this is a 2/3 fraction compared to a 1/6 fraction. Well, if I have the same size pieces, I can see that is a 4:1 comparison. And we can then show this as a division as well, because the ratio of comparison is essentially what division is. We're comparing the numerator of 2/3 divided by 1/6. And our ratio of comparison is going to be 4:1, or just 4. So when we do this as a ratio of comparison, we get this, but we also have a rule for dividing fractions. And for dividing fractions, what we can do is we can take our 2/3, and instead of dividing, we're going to do the opposite. And to compensate for this opposite, we have to do another opposite. So the opposite makes sure that we're doing the same thing. So this division statement, original division statement, actually can be done as a multiplication statement if we use this opposite property. And multiplication is going to be much easier to do than division, because now I can use my top times top, bottom times bottom, and I end up with the same answer of 4 that I got when I did my ratio of comparison.